say you are able to score A plus. A plus is the second grade, no? Second highest, no? Huh? And every day you are arranging the tripods. So I will upgrade to. Huh? So this I am saying on record. Is it on record? Huh? On record as an example. ठीक है ना? What is disclaimer here? बोलो से I say all these things, some kind of nonsense, just to draw your attention. है ना? So come out from that hostel mindset. What happened in the last night? So today, any doubt over that previous case study we discussed, the designing of vibration sensor or accelerometer? No? You have given two questions, na? The case study here we have taken that the input displacement is experienced by the mass. Remember? है ना? But the assignment I have given you, that is related to input. One time is towards the stiffness, that is appearing over the spring, and another time input is given to friction, B. Okay? So how will you get this in? How would you get this in? You think any major change in that primary design? Any major changes you require to do or any minor modification you need? Again? कौन तो भाई साहब reading mistake है no problem. In exam if you will do a mistake then you have to face the repercussion. Understand that question and then answer. Then I move forward. When you have given input to mass, what did you experience? Is it not? Okay? But if you will give an input to friction, in place of this, you will take. If you are giving input to spin, you will get what? That is the difference. Accordingly, you will modify your transfer function. Because in the other side, all three are participating. Your mass spring damper, no problem. Changing in the input side, right? So accordingly, you modify it. Your input side or output side? That is xi or x0? Check your expression. Whatever south of your heart will be, check your expression. Nobody is answering. Have you written anything? Can you cross check? Very good. Okay, so today we will start self-regulated process. Do that assignment accordingly. So what is self-regulated process? That a process which is able to control itself. Okay, without any external input. Getting my point? You, for example, I take an example of this tank. It has attained certain height h. It has attained certain height here. Okay. So in fact, I will take this point because that is the reference, and this height is, let's say, h. So this will give me the liquid level. Okay. That is my set point. That is the maximum boundary limit, because otherwise what happens, the fluid will be wasted, right? And one should not completely fill it. Okay, that is your inlet valve. You may or may not have valve, but normally we have. It can be a mechanical, it can be a sensor based automated valve. Whatever is the inlet valve. Inlet valve is open, so fluid is getting in to the tank or reservoir, whatever you want. Then there is another valve. Okay, here is outlet valve that restricts the flow of fluid to outside. Okay, now for example, you assume that the momentarily these two valves are not here. Okay, now fluid is getting. What will happen? It will get from filter. If there is a low valve here, you are also fitting at the same time. Now it depends upon the diameter of your inlet and outlet vessel or pipe. Check. If the velocity here of fluid flow is higher than the inlet, then it will never overflow. Right? On the other hand, if it is the reverse scenario, that the velocity of the inlet pipe or vessel is higher than the outlet velocity, okay, that is this pipe velocity, then what will happen? It will start keep storage, and if you are not doing anything, any external input, ultimately what will happen? The moment it will reach to the highest limit, and then it will overflow. Correct? If the velocity of both the vessels are same, then assuming that it is not empty, there is already 20% of water or maybe 10% of water something. So nearly the similar level will be kept on maintained and it will keep on filling. Okay, understand the example? Now which one is self-regulated, which one is not? Constant level, if both the velocities are same. Right now? Okay. Or the external velocity may be slightly higher. That means say 2% or 1% higher. Very minimal. So that is as good as equilibrium. Okay. So in that case I don't require to do anything. Understand? Now what do you mean by the control valve? What do you mean by the control valve? This valve, in terms of variable, you call it variable, no problem. Control variable. What is it? Output of the plant. We have seen that closed loop circuit diagram. Remember? Set point. Process variable is the feedback. ठीक है ना? Output of the controller is manipulated variable, and output of the plant is controlled variable, because it is being controlled by the controller. है ना? It is not self-regulated. Okay? It is always dictated and controlled and monitored by the controller, dedicated controller, right? So that control variable. So process is said to be self-regulated if the final control value, final output of the plant, final output of the device, final output of the system, okay, is adopted in such a way that for nominal load you don't require to take any control action. To maintain a nominal load, you don't require to take any external control action. You don't need it to take. Okay? Fine? In any circumstances, I don't require to put any external impact or effort to maintain the process of that particular system. Okay, so this is a reservoir system. Purpose is to store the fluid. Okay, there is a dedicated inlet and outlet channel through which the fluid can be passed in, can be stored and can be filled. Correct? So purposely here I have taken an open tank. If you will take a closed tank, if you will take a gas in place of a fluid, then the things will become little more serious. Okay, you definitely require dedicated valves. So let us go step by step. Now you assume that here some kind of heating sensor you have mounted. Okay? So there is a temperature indicator. I am writing here. Okay? So there is a temperature indicator here which is mounted and rest process is the same. Okay? Now what is the job of temperature indicator? It will give you all the time the temperature indicator. Okay? Now you started applied one heater as well. Here I add a heating mechanism. Here a heater is there. Okay? So what will happen? Your fluid will now start getting some thermal input. It will start getting heated. And to maintain the uniform distribution of the thermal input, let's say here we have given one input of steer also. There is steering mechanism, so it will keep on steering. Okay, so that otherwise what will happen? The bottom part of fluid will be more heated and the surface part will be relatively less. So to maintain the uniform temperature distribution, let us put a steering mechanism. Getting my point? Now, let us assume because of any reason this heater has become out of control. Out of control for a moment, not for always. For a moment it becomes out of control. Gone out of control. What will happen? What will happen? Understand this scenario now? Right? Okay? There is a heating mechanism. Because of any reason, now this heating mechanism is out of control. Okay? Rest all everything is the same. It is kept on continuing. It's a continuous process. Okay? Now tell me that scenario. Considering that scenario that your heating mechanism is out of control, can I recognize this system or this setup is a self-regulated process or not? No. Temperature is highly dynamic, no doubt about it. Temperature is highly notorious parameter. Probably one of the most dynamic and influential parameters on this earth. Okay? If you take the real life scenario, for example, you take get a second, just change is possible. Do you think that things will become out of control suddenly? Not suddenly, no? It will take depending on the size or the volume, the flow rate of the fluid, because fresh fluid is kept on coming. Yes, no? Let's say that if this heating mechanism is out of control, okay, and now I am assuming that either it is a free flow. Normally in application it is not free flow. Normally you always have one inlet valve. Okay, so I can increase the valve capacity. Okay, I can increase the capacity. Right? So I can add fresh fluid. So if I am adding additional fresh fluid and if this mechanism is out of control, can it be controlled for some moment or hours? Possible. So that means that is not out of control. So this disturbance you face. Understand now? Example. So this is the example of a self-regulated process. It is yet not disturbed due to this immediate problem. Getting my point? Now take an example. In place of let's say fluid, let's say earlier we assume water. Okay, now I am assuming this one is a rest arrangement is same, remember, this one is now a closed chamber, right? इसको मैं close कर दी, ठीक है? Now it's a closed chamber and this liquid is some kind of chemical composition. Some kind of chemical composition. Okay? Not simple H2O. है ना? H2O isn't it a chemical? नहीं. Is there ना? है ना? But we remain unaffected. है ना? Our body, our whole nature is designed accordingly. So it doesn't feel harm to us. That is also chemical. है ना? Let us assume a man-made chemical, something. Okay? Which is highly reactive. Understand? Now you assume that that is stored in place of that simple H2O. Fine? Rest arrangement is same. Right? Even for a simplicity, either you can assume that there is a heating mechanism, but remember that if it is a chemical, we will never do this. That we try to heat something within the closed chamber, even if it is for a few seconds only. Okay? So either you assume that your heater is not continuously on now. I am changing scenario. Either it is on for a few seconds. Okay? That means it should be in a controlled way. If not, then you will remove this entire system. But rest all is same. It is a closed chamber. In place of water, now it is a chemical fluid. Okay? Now tell me whether it is a self-regulated process or not. There is a no control to inlet valve. There is no control to outlet valve. Inside some chemical is stored. And you are stirring it. You are monitoring the temperature inside the chamber, because if it is a closed chamber, always I have to monitor. Probably in place of along with temperature. Probably here I will prefer to fit one pressure indicator also. Isn't it? Pressure indicator will give me the inside pressure of the closed chamber. Temperature indicator will continuously provide me the inside temperature. Because I need to monitor. Whether you are stirring it or not, whether you are heating it or not, doesn't matter. You have to keep on monitoring. There is no external medium. So I can fix some proximity sensor or something to do this job, whatever. But now tell me, is it a out of control scenario or not? If the things is not properly regulated, and if it is a very reactive chemical, then things can go out of control or can go. There is a probability, high probability. Okay, so do you want that? Don't you want to control this scenario? You want, so then it is not an example of self-regulated process. Here is mentioned chemical reactor as an example. You can take any such example. Understand? Don't require the references. Consider the scenario 3, liquid level, like in the previous case I have shown. Forget about the temperature, forget about the chemical. Now it is the same tank. We can assume that open tank or closed tank, doesn't matter. But the outlet valve, okay, outflow is not depending on this head. Head means like this. Somewhere you might have seen this symbol. Okay, that mechanical valve. Pipe open करते हो, पानी पी लेते हो. When you close it, tap, simple tap. Take it as a simple mechanical valve. ठीक है? Okay. Now assume the scenario that tap is not there, or reverse. The outflow doesn't depend on that head. That means there is no outlet valve. Okay. Now your things will distort or not? May distort. If there is no outlet control, and if you have not taken a proper control, because I cannot make sure that input is always 24/7. Water supply is for the limited time. Morning hour में supply होगा half an hour, evening hour में supply होगा half an hour, not for all the time. Or your municipality has taken the responsibility. No, sir and madams are very busy. Let me keep on supplying. Not na. Otherwise you do not have a overhead concept. Why you keep the overhead tank? Just to ensure that you store sufficient amount of water, so that rest of the day I can utilize it. Unless the fresh supply will not experience in the next day, very next day. Yes? So in that scenario what will happen? If I will not put any check here, my tank will remain empty, or will be empty after some time, few hours. So things is not going in the controlled way. That is also not an example of a self-regulated process. Okay? Yes. If you can do something that I am not putting any check over here, but rather what I am doing, that let me take a scenario that here you have some motorized action, okay, or the control flow action. I am taking that this valve diameter is much lesser, thinner than this valve, and here I am putting one outlet valve to supply the external current, okay, or to feed the external current. Here I take a deliberately low diameter pipe, okay. So this portion I will do. Clear means entire thing will clear or what? Okay. So in that case, what will happen? Now you see, that was the fluid in, this value. There is, you can assume that there is some motorized action, no problem. Okay. If not, that is good. That's why you can take this one is a thinner diameter. What will happen? Portion of water will move in this direction, and because here the size is less, so you will get the increased velocity automatically. Okay? So the large chunk will move in this direction, but remember this is against the gravity, okay, and this one is towards, with the gravity, not through the gravity, but towards it on the same line. So the portion of the supply will move in this direction, that will consume. The portion will move back in this direction, and here you have a reservoir, you recycle it back. Because this part is inlet, this part is reflow. Understand? Now, if you can arrange this kind of scenario with or without valve, both is possible. Obviously, with valve is more efficient, without valve can also be done. Think about it. Okay? Then, that is the example of a self-regulated process. But obviously, in that case, you need to involve what is mentioned here, some resistance element. Don't you think that that valve is a resistive element? Isn't it? It restricts the flow of fluid, no? So that acts as a resistance. Like our electrical equivalent resistance. It restricts the flow of current. Here it restricts the flow of fluid. So it is as good as a resistance. Okay? So each valve acts as a resistance. Okay? So here I can make sure that one valve is here. Here I can make sure that it should attain the higher increased velocity as compared to this fluid. So it will make sure that even against the gravity, some considerable amount of portion of water will be back and inside. Clear? Okay? Then you can assume that this is an example of self-regulated process. Okay? There is a, tomorrow you assume that there is a nitrogen processing plant. You are getting in that nitrogen. Now nitrogen is stored in some closed vessel. In the liquid form you store, or in gaseous form. Gaseous or liquid? Liquid form. Why? Restrict the volume. Otherwise you require, right? Na? So obviously when you are restricting, that means you are compressing it. So compressing means naturally whatever inside pressure is, that is more than atmospheric pressure. So now continuously I have to take care of those engineerings. I have to involve special instrumentation to take care of the inside pressure, temperature, closed valve, closed chamber. Okay, now it is pressurized. So don't you think that the temperature will also shoot up? Definitely. So you have taken care of the temperature indication also. Okay. Now what is the level of nitrogen, liquid nitrogen inside the tank, that you also need to monitor. So you require one level indicator also. And now you are filling that nitrogen from somewhere inlet valve, and you are feeding it also, feeding through outlet valve. So you require two monitoring setup here also. That means I require flow indicator also. Yes or no? So I need flow indicators, I need temperature indicator, I need pressure indicator, I need what? Level indicator. Indicator, that means that will display the data. Transmitter means more than an indicator. It will not only display, it will propagate the data. To whom? To controller. A controller may be 250 meters away, maybe 2 kilometers away. So it's a duty to keep on propagating the data, transmitting the data. Okay, this is my current scenario. Accordingly, you take your action. Okay, because these devices are slave. Who is the master? Controller. So now controller will take the decision. Okay? So in that scenario, what do you think? Now that nitrogen is fed. So there are two scenarios. Either that nitrogen will be completely consumed. So in one side, it kept on generating it, kept on storing it, process it. Process it means you take care about this depressurization of the tank, filling of the tank, okay, feeding of the, and then again depressurize. So this filling, feeding, pressurizing, depressurizing action you have to control, because that is a closed tank. That is called processing part. Another thing is feeding. So when you feed that nitrogen, it is produced for some purpose. Understand? So there will be different applications in your industry. Now either there is two scenarios. Either that fed nitrogen will be completely consumed. Okay? So it's like a unidirection. It is also possible that the portion of nitrogen will be used for some purpose. Let's say for example to eject the heat. Normally we don't use nitrogen, we use something else. But okay, just an example I am saying. Okay? Let's say you use that particular nitrogen because it is stored in a very low temperature. So ultimately if I will pass through some heating media, what will happen? It will extract those heats. Now that hot nitrogen will be coming out. I have a two way. Either let me just eject into the atmosphere. That is one. Second thing what I can do, because I invest a lot of money to extract this nitrogen from atmosphere and then process it and then feed it. Should I just allow it to exhaust? If no option, then fine. But if there is an option, what I would prefer? Whatever the rest is remain after consuming, I will try to recycle it back, so that my system will become more efficient. Next cycle के लिए क्या होगा? I have let's say 10% of utilized nitrogen. I will again reprocess it, but मेरे को atmosphere से तो extract करने की जरूरत नहीं ना. So next time I will extract 90%. So with an investment of 90 rupees, I am getting output of 100 rupees. And this process is kept on going. Understand my point? So that way you need to take a decision that whether the process can be self-regulated or not. But the condition of self-regulation is this. Understand? If you do not require to take any special control action to regulate the process or to deal with the process, then it is called a self-regulated process. If it is, then these kind of processes will be very reliable, very robust and very cost effective. As compared to a process where I need continuous control action. Understand? Let us say there is a one term which will be I mentioned. We talk about this 3-4 terms. There are many parameters. Parameters or variable. So there is a flow, there is a pressure, there is a level, and there is a temperature. Why I mention these four? Because if you look at the industry applications, any industrial application you do, these four are always there. That is never ever possible that these four parameters doesn't exist. At least one among those will be there, or maybe more than one will be there. Understand? Clear? Now if the flow is there, okay, so depending on that, if it is a simple open reservoir, I am trying to store some standard fluid like water, I need not take any special care. I can feed some indicators, fine, but I don't require. But if it is a closed chamber, then I need to take care of the pressure inside the chamber, I need to take care about the temperature inside the chamber. And now let us assume that in that closed chamber, the level of stored nitrogen is kept on increasing. What will happen? inside pressure will change or that will remain same? Change. And if you have started consuming that stored nitrogen and the level of nitrogen is now decreasing, then the pressure will remain same? No. But if the pressure is changing, what do you all think about temperature? Temperature will also change. Yes, no? So sometimes you don't require to deal with one efficient control or monitoring of one of the parameters. You probably require to take care of other dependent parameters as well. Your purpose is to monitor the temperature, but because the scenario is a closed chamber, it is a liquid compressed gas. So whether I want it or not, I should monitor the pressure and level as well. If both the inlet outlet valves are closed. Now if one of the valve is open, I need to regulate again the flow, because depending on this flow, level will change. If level is changing, then your pressure will also change. If pressure is changing, then temperature will definitely change. Right? Okay? So in these scenarios, earlier we have considered till now that you require minimum twice of the bandwidth. You are all have studied that the maximum operating frequency of a signal is Fmax and the sampling frequency is Fs. So what is your sampling zero? Is it not? Is it not? Okay, now that is it, na? Greater than or equal to. So remember, practically there is no equal to. This is a theoretical statement. Practically it should be always positive. It should be little above that noise FM, so that the adjacent sample should not interfere with it. This is clear, na? Considering this, do you think that this one will be applicable in this industry scenario? When you studied that sampling theorem under the head of communication, what was your input signal? That is the characteristic of signal. What is the input signals or variables? Voice, audio, video, some text message, for example fax. Right? Normally fax operates at double of your standard frequency. If we ourselves design a fax machine, we will operate at 100 Hz. If you are just buying a technology from US, then it is 120 Hz, because they operate at 60 Hz. Okay? Now, do you think that the same criteria will follow to deal with the notorious parameters like flow, temperature, pressure? The way you are able to handle a voice or audio signal? Not possible. So therefore, that statement if you will apply here, your system will fail, because controller may get some data, may not get some. Okay? So there is a range. What we do is the flow. We normally take, it is advisable to take 1 to 3 times of your Fmax. That will be equal to your sampling frequency. Now 1 means same. 2 times is your criteria, standard criteria. So what should I take? If it is a noisy environment, if it is a noiseless environment, okay, I can go twice a day, no problem. Okay? But if it is a real field environment, then I will go for how much? 3 times of, if the variable or input is a flow. Okay? So out of 4, this flow is a most gentleman pattern. Least notorious. Then come to the pressure. What do you think? If temperature will change, do you think that suddenly flow will interrupted? तुमने fluid flow suddenly double कर दी, velocity is double. Do you think that temperature will be also double? No, vice versa. Temperature is just double. डबल कर दिया तो फ्लूइड फ्लो डबल हो जाएगा? नहीं ना, अफेक्ट्स बट नॉट दैट मच, करेक्ट. बट व्हाट अबाउट प्रेशर? That may get affected due to the flow. Yes or no? So I need to take little extra. I take here 1 to 5 times of maximum operating frequency of what? Of the data you sensed right now. So your sensor has sensed the data. It has some operating frequencies, है ना? For example, वॉइस में तुमने लिया था ना 0 to 4 किलोहर्ट्ज, तो 4 is my f max. Theoretically, practically it's around 3.4 kilohertz. It's not actually 4 kilohertz, but you are okay. Ideal range is 0 to 4, है ना? So my f max is 4 kilohertz. So my sampling frequency should be above 8 kilohertz. That's your calculation, na? So here it should be 5 times. So this higher range is actually telling you that who is more notorious. Understand? Why notorious? Because it is influenced itself due to the variation of other parameters. It not deliberately, naturally it depends on something else. Okay? Flow may not be that much depends on pressure, but pressure is definitely affected due to it. Okay? Come down to level. It is roughly around 5 to 10 times of maximum operating frequency. Worst case you will take 5 times. है ना? How do I know? How do I know? हैं? सारा असले कहिदेले मानजिव हैं? अरे so each one of you from today onwards is going to do, I mean including homework, when you will get back to your hostels. So from today onwards, 1st February onwards, we take a new resolution that whenever I will go back to hostel, reach to my room, I will get clear myself, and then I will at least study 8 to 10 hours in a day, other than the college hours, and macroeconomy, microeconomy, blah blah blah. Different clubs, technical club, social club, music club, sports club. ठीक है? नहीं, not agreed ना? Show me your agreement or disagreement here. It's around 5 to 10 times, depending on again the external disturbances. And if 5 times is insufficient, go for 6, 7, 8. Even sometimes 10 times is also allowed, because rest of the protocols, that means wireless communication or wired communication protocol, are designed accordingly to satisfy these needs in industrial environment. Okay? Okay? We want the simplest form of data, but this is one of the reasons. This is one of the reasons that why the systems are very costly. Not just that it is just an industry application and you go for this. Okay? Not just that it is an industry application and I need to deal about this. Clear? How much time left? Done?
57.
57. One thing, you have 3 seconds. 57. Very good. आगे का मुक्ति मिल रहा नहीं? Okay. What was the last? Temperature? Temperature? Can be influenced due to variation in level? Yes? What is it? Can be varied due to the temperature? Temperature may vary due to the variation in level or not? Can vary due to the variation in pressure? Enough? And up to certain limit will also affect due to the flow. Take the same vessel, increase the velocity of the fluid flow, what will happen? And then you simply touch. Consider even water supply. And then you touch that the external surface of the vessel. You will feel little bit of it. Yes, no? Okay? Flow is not that much dependent, but temperature is dependent. But up to not that extent, but you talk about the pressure or level, but up to some extent. That is in the order. Okay? The least is the flow. Right now? The least is the flow, then pressure, then level, then temperature. So dynamics is increasing in this direction. Okay? So here we take 1 to 3 times, here we take 1 to 5 times, here we take 5 to 10 times. What do you think about temperature? 10 times? 10 to 20 times of maximum operating frequency. That is the sampling frequency you need to take, so that you can factfully generate these digital data and then transmit to the controller. Otherwise, your controller may need to take a incorrect decision. Okay? Obviously, higher the sampling size you are going, more the cost you get to incur. So, if my FM is equal to 1 kilohertz, so 10 times of FM is 10 kilohertz. Na? So next sample I can take again of 10 kilohertz. Difference भी रखना पड़ेगा. Let's say 20% variation. So difference between two sample is 2 kilohertz. If the sample size itself is 1 kilohertz, so at least difference तो मैं रखूँगा ना दोनों के. Otherwise there will be interference, interlacing होगा ना, overlapping. So to avoid any overlapping, so that both the samples should not superimpose over each other, what is the distance between the two central point of the sample? 22 kilohertz. But if my maximum modulating frequency is 5, then with 11 kilohertz itself I can manage. So that means with the same bandwidth, the double sample I can fit. Possible, na? Huh? So कौन देगा इसका पैसा? हैं? The operation cost you have to manage, na? That is the point. Okay? So this is the reason we came to avoid, to retain your desired amount of signal to noise ratio. These are the standards for these parameters. Getting my point? So in the next class we will continue the class, and along with we will talk about that current voltage.